Part 3, writing an equation from a graph. Write an equation for the following graph. Looking at this graph, I can see that our parent function, or our toolkit function, would be square root of x. Remember the basic shapes of your toolkit function. So let's graph square root of x and compare. If we have square root of x, I have the point 0, 0, 1, 1, 4, 2. I know what that shape looks like. So what happened? One thing I can see that we were reflected about the y-axis. So reflected about the y-axis means I'm going to have a negative x in the square root. I can also see it got moved down 4. This point that was at 0, 0 is now down here at 0, negative 4. And it looks like I have a vertical stretch. It's hard to say exactly what that vertical stretch is without looking at some points. We have this point right here at negative 4, 2. So whatever my final equation looks like, if I substitute negative 4 for x, I need to get 2 for y. So I know I have a vertical stretch here. Let's just call that a. If I put 2 for y and negative 4 for x, then I have 2 equals a times the square root of negative 4 minus 4. Or 2 equals a times the square root of 4 minus 4. So 2 equals 2a minus 4. Add 4 to both sides, I get 6 equals 2a, and a equals 3. So my equation should look like y equals 3 times the square root of negative x minus 4. You could find another point and substitute it into the equation to make sure it works for another point also. Let's try one more. Write an equation for the following graph. Looking at this, I can see we have an absolute value function. Our toolkit function that matches would be the absolute value of x. This function did get transformed. We can see it got moved to the left 2 and up 3. So this is our point negative 2, 3. That's our new vertex. So that point went from 0, 0 to negative 2, 3. So when I write my function or my equation for my new function, I know that inside the absolute value, I'm going to have an x plus 2. And I know I moved up 3. And then I have some kind of vertical stretch here. Let's see what that is. I have a point right here at 0, negative 1. So if I put an a in front of the absolute value and I need to find what that a value is, I know when x is 0, y is negative 1. So I have negative 1 equals a times the absolute value of 2 plus 3, or negative 1 equals 2a plus 3. Subtract 3 and I get negative 4 equals 2a. Divide by 2 and I get a equals negative 2. So my equation now is y equals negative 2 times the absolute value of x plus 2 and then plus 3. To double check that this works, let's find another point. Here we have a point negative 3, 1. So that should work in my equation, negative 3, 1. So if y is 1 and x is negative 3, then I have 1 equals negative 2 times the absolute value of negative 3 plus 2 plus 3. So 1 equals negative 2 times the absolute value of negative 1 plus 3, or 1 equals negative 2 times 1 plus 3, which does equal 1. So that looks good. It works for another point also. That's just a check to make sure. Here is our equation to match this graph.